Okay, well, hello friends. This is a very short tutorial, not even a tutorial, but just an overview of just starting jet engines, starting the engines up on the 737, and just to illustrate how the aeroplane is and can be self-sufficient. So you find us here at a very strange location. I've got some free scenery for Elstree that I hadn't had a look at yet, and as part of this quick video I needed somewhere that didn't have gate power, and I wasn't going to muck about at a big airport trying to find a gate that didn't have any gate power, and I thought where better to come than just here to A, have a look at the scenery. You can see I've got no ortho on, but I've got the scenery loaded up, and B, just to ensure that there was no ground power available, so the aeroplane is sat on the grass very unrealistically, but it's not going anywhere, so it doesn't matter. So with that little intro over, let's hop into the jet. It's just Delta because that's the last livery that I flew, and again that doesn't matter, it's going to be the same for every version. So here we are in the cockpit, completely cold and dark. You can see that there is no ground power available. So the aeroplane is completely isolated, a bit like I did a flight from Fiji to Hawaii that stopped in Kiribati, and that was literally the middle of nowhere in the Pacific. A runway, we had to get off the aeroplane and just sit by the terminal. There was toilets and that was it. There was no cover, no shade. It was just literally a building, and so I don't think they had any ground power there. So what are we going to do to get the aeroplane working? First things first, the aeroplane needs some DC power. And like I say, I'm just going to prep the aeroplane and show you how easy and quick you can start the engines up with no other preparation for flight. So we're not going to do any of the RSs, nothing. I am going to have the steady lights on once we get AC power, just because them's the rules. So, battery comes on, and you can hear everything load up. The emergency exit lights can come on. And that is it. I'm even going to leave the fuel pumps off just to show you that the APU and the engines can start without them. So you can see that there's a few things lit up. We've got some fuel. You can check the takeoff config warning, but again we're not going flying, so we don't have to do that. And you can see that there's a couple of errors like the anti-skid in op because we've got no AC power. Just because we're on DC, you can see here that we have only one side of the aeroplane lit up and working. That's how it works. So we are going to get the APU on, push and hold for 3 seconds, and you can see that the APU EGT is running. So the APU will start off of DC power. It is designed to be done like that because obviously if you're in the middle of nowhere you need something to generate AC power, and it's just a small jet engine at the back of the tail. You can see it will start. We normally have one of the fuel pumps from tank 1. If you look at the fuel diagram you'll see why, providing pressure to the APU when it's running, but obviously these need AC power, so until the APU is on you won't get anything. And the APU gen bus light means that the APU is available, so selecting both bus tyres will then power the aeroplane up with AC power. And from the rear you can see a bit of exhaust. You can see the exhaust here, and you should, through the magic of Zibo, be able to see the APU inlet here is open and allowing air into the APU in the tail. So the aeroplane has now got AC power. We've got the position lights on steady, and we need to fire up the engines. We literally don't need to do anything else other than turn the APU bleed on, ensure that the isolation valve is open. You would normally have the packs on here because they will provide conditioned air to the cabin from the air conditioning panel here. That's a usual setting that you'd see. So of course if it was spectacularly hot outside, you know, if we were in Spain in the summer, 30, 35 degrees, 40 degrees in the cabin would not be unreasonable. You can see the cabin, passenger cabin here, forward and aft, temperature sensors at the top, so you can see exactly what the cabin is. It's close to ambient temperature, relatively comfortable. And to start the engines you have to have the packs off, so a normal configuration, when we fire these up you will hear the packs, you can see the duct pressure drop a little bit, and the cabin will probably start to warm up slightly to be around 20 degrees. but the engines won't start with the packs on. So that's the sort of configuration that you should see. APU bleed on, engine bleeds stay on unless you're doing a bleeds off takeoff, packs in auto. To get the engine started, all you have to do is turn the packs off, pop the anti-collision light on. You don't have to do that, but it is aviation practice to have beacons on when engines are about to be started or whenever they are running, so you should do that. Engine instruments are displayed here, and all we're going to do is start engine number 2 by turning this to ground, the start switch to ground, and you'll see that instantly N2 starts to rise. You can hear the engine starting up, and what we're looking for is max motoring, so either N2 stops or 25% N2. It should usually be between 20 and 25%, and once we get there we simply put the fuel on. Down here I have it mapped to a hardware. Fuel goes from cut-off to idle, and then N2 will start to accelerate, keep accelerating, and at, I think it's about 56% N2, you will hear the starter cut out, and that is the start valve shutting. You can check the oil pressure. There you go, starter cut out, valve goes off, and the engine will now be sufficient by itself. Once you get approximately 20, 462, 46, the engine is stable, and you can. Nothing else is needed to do on the upper overhead. Simply start engine number 1. The same thing will happen. Hear the engine spool up, start valves open, need oil pressure, so you can check that. In the sim, unless you've got failures enabled, you should always see oil pressure operating normally. Of course, as we get oil pressure, the light goes out. Now, I've just left it there to see what happens. The engine will continue and it will plateau at an N2, and nothing more will happen until you put the fuel on. You can do it by hand, a bit more difficult. And again, the engine will accelerate. The starter switches above have got solenoids, so when they're set to ground, when the starter valve and the cut-off shuts, it will set it back to off or auto, whatever the neutral position is, depending on the airframe. There's the starter valve shut. The engine is now accelerating. And there we have another stable engine, 246. A fuel flow, this is in pounds, of 65, it's about 30 if it's in kilos. And that's it. That's literally it. It's as simple as that to start the engines. You can then do the flow, and I will run through the flow, which is to turn the turn the engine generators on. The APU bus is then off and illuminated. You can turn the APU off. Start switches to continuous. Probe heats come on. Anti-ice as required. Pumps should normally be on. And you go down, up, and a reverse C for the AC panel. You've then got some flying control checks to do, but that is it. There is the checklist here to go through for the before taxi, and you can follow that, but you do the flow first, and then you check it. In a multi-crew aeroplane, you will call for the checklist to check that you've done the flow correctly. And it's as simple as that. So, if you've watched, that video is probably longer than it needed to be with a little bit of extra information, but less than 10 minutes, and if you are struggling, I hope it helps. So, from me for now, thanks for watching, take care, and I hope to see you again soon. If you like the video, please like, and if you want to see more, please